Hi, good morning everyone. Today we're going
Morning.
to discuss the second activity, which is the presence and absence of enzyme in a chemical reaction and the effect of temperature on enzyme activity. And I'm Putri Sabrina with the matrix number of 182201.
I'm Dong Wei-Sun, matrix number 181588.
Okay, my name is Angel with the matrix number 183825. I'm Sri Suhaila Muhammad Ma'ruf with matrix number 181636.
My name is Abdul Rahman bin Manafi. My matrix number is 182082.
My name is Tushan Ramachan, matrix number 181290.
We'll start with discussing about the experiment we have just conducted just now. We'll talk about the aim first. For this experiment, the aim is to determine the reaction rate in the presence or absence of an enzyme and to determine the effect of temperature on the activity of an enzymatic reaction. So what are enzymes? Enzymes are specialized proteins that can act as biocatalysts, which speeds up the chemical reaction that occur in cell without itself being consumed or changed at the end of the reaction. Reactions that break down molecules and those that build up molecules all require enzymes. Enzymes work by lowering the activation energy of the reaction, and the reaction will proceed much slower without the presence of enzymes. Enzymes are also highly specific, and their activities are affected by certain factors such as the temperature and pH. Well, enzymes can only function in a certain range of temperature and pH because the temperature and pH beyond the optimum condition will denature the enzyme, which is a protein. So temperature plays a significant role in the speed of reaction. When temperature increases, the substrate and enzyme molecules will gain more energy and increase the movement of the molecules. This in turn will increase the frequency of effective collision between the molecules and speed up the reaction. So most enzymes function the best at moderate temperature, but there are some that functions best in high temperature.
In this experiment, we study about enzyme cellulose, an enzyme involved in the low step of breaking down of cellulose. In the experiment, an artificial substrate, p-nitrophenol glycopyranuside, is used instead of real cellulose. A disaccharide composed of two beta-glucose molecules. P-nitrophenol glycopyranuside is broken down by cellulose to produce glucose and p-nitrophenol. P-nitrophenol, when mixed with basic solution, appears yellow. The intensity of the yellow color is directly proportional to the amount of p-nitrophenol present. Therefore, it can be used to estimate the amount of product formed in each set of the experiment. In this experiment, we use spectrometer, which quantitatively measures the amount of yellow color by shining a beam of light through the sample and measures the amount of light absorbed by the sample. The higher the intensity of the yellow color indicates the more light that is absorbed. Hence, more concentrated is the sample.
Okay, so there are several methods to do the experiment. First, we look at 15 ml conical tubes level stock solution, substrate, enzyme, and buffer. Each of these tubes are labeled with our group initials, and then the 5 cuvettes are labeled with E1 to E5. This is according to their time points. For example, E1 is for 1 minute time points, E2 is for 2 minute time points, and etc. And then remember to only label the upper part of the cuvettes, and then we cannot touch the lower part of the cuvette because it will disturb the reading of the absorbance when we use the spectrophotometer. And then the remaining 2 cuvette is labeled start and end. On the upper part of the cuvette will serve as control time points at the start and end of the reaction, and neither cuvette will contain enzyme. So the E1 to E5 will contain enzyme, but the start and end will not contain enzyme. Using a clean micropipette, we pipette 500 microliter of stock solution, this one, into each of the 7 level cuvettes. The stock solution is a strong base, so we must be careful so it doesn't getting on our skin or clothes. The micropipette must be washed well and then sweet water. And then the two empty 15 milliliter conical tubes are labeled one enzyme reaction and one more control. Using a clean micropipette, 2 milliliter of 1.5 millimole substrates is pipetted into the 15 milliliter conical tube labeled the enzyme reaction. And then use the same micropipette and pipette 1 milliliter of 1.5 millimole substrate into the conical tube labeled control. Okay. Then rinse the micropipette well with water.
I will continue from my friend before. So the next step is we have to micropipette 500 microliters of buffer solution into 15 milliliter conical tube, which is labeled control, and then another 500 then we pipette another 500 microliter from the control tube into cuvette, and then the cuvette is labeled to start. This is as control, and then we continue to the variable of the experiment. So we pipette 1 ml of enzyme into enzyme reaction. Enzyme reaction is already contains substrate, so once we put in the enzyme, the reaction will quickly start. So after putting the enzyme reaction tube, we start to mix it slowly, and then after mixing, we quickly start our timer. This is because this part of the experiment is really time sensitive. So, and then after that, after starting the timer, we micropipette 500 microliters of enzyme reaction, which is the one before, into the cuvette solution according to the times label on the cuvette. So after 1 minute, we put in into the E1, which is 1 minute, and then 2 minutes, and then 4 minutes, and then 6 minutes. In this cuvette, it has a stop solution, which is high concentrated alcohol, which stop the reaction because it changes the pH value of the solution, and then it also provide indication for concentration of product form. And then for the control, we micropipette another 500 microliter to the 8-minute cuvette, which is the end cuvette. So after finish with all of these steps, we use the spectrophotometer to determine each cuvette, the light intensity from cuvette. Okay, thank you.
So for the next activity that we carried out, which is the effect of temperature on enzyme activity, first we had to label 4 cuvettes with 0 degrees Celsius, 22 degrees Celsius, 37 degrees Celsius, and 90 degrees Celsius. Then we had to micropipette a stock solution into each cuvette, and then we had to use a microcentrifuge, 4 microcentrifuge, to fill in with 250 microliter of enzyme, and we take another 4 microcentrifuge to fill it with 400 microliter of substrate.
Okay, for the next step is the microcentrifuge tubes will be labeled 0 degrees Celsius enzyme and 0 degrees Celsius substrate will be placed inside an ice cup. And for the rest of the tubes, they will be placed and will be allowed to equilibrate to their respective temperature for at least 5 minutes. Then we will set a stopwatch like this, and we will pipette the 250 microliter of enzymes from the tube labeled 0 degrees Celsius enzyme into another tube labeled 0 degrees Celsius substrate, and then place back into the ice. And the same step is repeated for the rest of the tube, and the stopwatch is started. And after 2 minutes, pipette each temperature reaction to transfer 500 microliter of the reaction to the appropriately labeled cartridge containing stock solution. and all the solutions are around the room temperature for approximately 5 minutes. All the data are recorded in a table, and